Hey guys, we're back. We're doing section 1.3 part 2. We're picking up at average rate of change. Now this idea looks a lot like slope, okay? So hopefully this comforts you. So if we're talking about a secant line is something that hits 2 times on a curve and it draws a straight line between it, okay? A secant line is joined between 2 points on the function. Finding the slope of the secant line through those 2 points will give you the average rate of change. So the way that we state this point here is that this value is c. As we go up, we call this y value f of c. So we say this is the point c comma f of c. And if this is the point where x equals x and we follow it up, its corresponding y value is f of x, okay? So our horizontal change here is x minus c, so our bigger number minus our smaller number. And our vertical change here is f of x, the higher number, minus the f of c, which is our lower number. So this is our horizontal change, and this is our vertical change, okay? That sounds like slope, like rise over run, right? So this is what you need to remember, that the average rate of change is the change in y over the change of x. So those of you who've used chemistry before, you knew that that triangle is delta, which means change, okay? Which is the slope of the secant, where f of x minus f of c all over x minus c. Make sure that you have that written down. So this one says find the average rate of change where f of x equals x cubed minus 3 over the interval 1, 3. So here's what this means. That the average rate of change, we're going to find this is going to be our first value of x and this is our second value of x, okay? So let's find f of 3 and let's find f of 1. So I know that instead of x cubed minus 3x, we're going to use 3 cubed minus 3 times 3. And then instead of x cubed minus 3x, we're going to use 1 cubed minus 3 times 1. So f of 3 equals 3 cubed, which is 27. 3 times 3 is 9, so this becomes 18. And f of 1, we're going to say is 1 minus 3, which is negative 2. So once we know those two values on our function, now we can find the average rate of change. So we know that's going to be f of 3 minus f of 1 all over 3 minus 1. Well, we know f of 3 is 18, so we're going to put that here. And f of 1 is negative 2. Don't forget those negatives matter. And then let's simplify. So we get 18 minus negative 2 is 20. All over 3 minus 1 is 2, and we get 10. So our average rate of change on that interval is 10. All right, let's look at our next page. It says comparing functions and interpreting graphs, okay? So we turn our focus and attention to the comparison between two functions. Oftentimes we want to find y values where a function is positive, negative, or 0. So that's what we're going to be looking at here. We're going to write some mathematical statements for functions to represent each verbal statement. So we're going to read it verbally and then put it in a mathematical statement. So if a point x comma 0 is located on the graph of f, well, that tells me, since our y value is 0, that's also telling me that the function in terms of x, or where our input is x, equals 0. Second one, two functions f and g intersect at a given point. So that means if the point, let's say, is x, then f of x is going to equal g of x at that same value of x. Part C, it says a point lies above the x-axis on function g. So remember, the x-axis is here. If it lies above it, it's going to be somewhere above it like this. This tells me that their y values are always going to be above that line or above 0. So we can say function g of x is greater than 0. Next one, part D, it says a point lies below the x-axis. So again, if this is my x-axis, all of that graph is going to lie below it, which is going to be those negative values. So we can say, because it's function f of x would be less than 0. Part E, the graph of f lies above the graph of g. So if f of x is above g of x, it's greater than. Okay? And f, the graph of f lies below the graph of g. So if f of x is below g of x, we say less than. Okay? So let's talk about functions with multiple representations. So remember we talked about gnawing on different representations. So if I look at this graph here, there's a couple things that I notice. I know that, like, for example, if this was at -3, if I follow that up, that point where f of -3 is, it equals 4. I also noticed a couple things. If I picked x was 2 and I follow this up, I would get f of 2 also equals 6. Okay, and if I notice that this is y equals f of x is graphical, the other chart that they're giving me is x and g of x. So this is a different function. So these charts are not the same function. They're representing two different functions. Okay, so it's telling me, hey, when x is -6, we get g of x is 4. When x is 0, we get -3, and so on. So let's look at how we can use these two expressions of these functions, f and g, to solve. Okay, it says find the value of 3 times 2f of -3 minus 4 times g of 0. So first things I want to do is identify what information I still need. So I need to find f of 3, and I also need to find g of 0. So let's see if I can plug that in. So instead of f of -3, remember this is my f of x function. If I go to f of -3, I get my answer is 4. So this becomes 4. So I can write the rest of this down, minus 4 times, what's g of 0? So I know this is my g function. When x is 0, my output is -3. Okay, so now we've got all our values, and we can just use PEMDAS. PEMDAS has parentheses, so that's 8. Again, here we get -12. And then we do again in our second parentheses, so this is 8 plus 12 is 20. Times 3 is 60. Okay? Part B, it says given h of x equals ax squared minus 4x, so remember a is an unknown, what values of a is h of 3 equal to f of 2 minus g of -3? So first we need to find some values here, okay? So number 1, I want to find what h of 3 is. So what's h of 3? So if this is my h, okay, h of 3 is going to be written as a times, instead of x, we use 3 squared minus 4 times 3, okay? So all of this, h of 3, is this, okay? And we're going to set it equal to f of 2. So what is f of 2? F of 2, so we're going to go back to function of 2 right here. F of 2 is 6 minus, what's g of -3? So here's my g function, here's -3, the output is 1. So I'm going to fix all this. Now that I plugged in those values, we're going to solve. So I get 3 squared is 9 times a minus 4 times 3 is 12 equals 6 minus 1 is 5. Now this is an equation I can solve, add 12 to both sides, and I get 9a equals 17. Divide both sides by 9, and I get a equals 17 over 9. Okay, let's talk about comparing functions graphically now. Okay, so it says use the values of function f and function g at the right to see what's going on at the following. So a couple of things I want you to notice. There's a couple places where these graphs intersect each other. So if I'm following f of x, so here's like f of x, and here's g of x. Okay, there's a couple of different places we see some intersections here. So I see an intersection here, I see an intersection here, and I see an intersection here, where in those intersections, those graphs change how they are in relationship to the other graph. Okay, so here I can see that f of x is below g of x, to start until x is negative 8. But then after x is negative 8, f of x is greater than g of x until that changes again at x equals 2, where f of x is less than g of x. And then at x equals 7, f of x is greater than it again. So let's go ahead and write the domain for each function. So f of x, I can see it goes from left to right forever, so we say the domain is from negative infinity to infinity. And g of x, the same, goes forever from left to right, so we say they both have the same domain. There's no restriction on x, they're both continuous. Part B, the values of x such that f of x equals 0. So where is f of x? F of x is that neon green one, okay? So if f of x equals 0, we want to know where does it cross that x-axis. So I can see that it crosses right here, and that's at x equals negative 9. Okay, same thing for this next one. Okay, where does g of x equal 0? So that's this graph right here, and we want to know where it crosses this x-axis. So it happens here and here, okay? That's where x is negative 6 and x is negative 2. Also, if you kind of zoom in to the right over here, it's not exactly, whoops, let me move this out of the way. Here we go. If I zoom in over here, I can see that if I'm continuing this graph here, this is going to continue at 11, 12, 13. So if you really looked at it closely, we would see that it's also going to continue at x equals positive 13. Part C, it says find the values of x such that f of x equals g of x. So that's going to be where they intersect. Those are all those purple dots, okay? So that's when x equals negative 8. Here, it's not exactly right on the graph. So I'm going to go, it's about a third of the way past 1. So I'm going to say that's 1 1/3 or 4/3. And then the last one is where x equals 7. Okay. Part D, it says, what are the values where f of x is greater than g of x? So remember, f of x is the green and g of x is the red. So we're looking for where is f of x above the g of x. So we see that here and we see that here. So what are the values of x? So starting at where x is negative 8 and ending where x is that 1 1/3. So if we say from negative infinity to that 4/3, and then it starts again when x is 7 to infinity. Part E, let's talk about when f of x is less than g of x. So that's when that green graph is below the red graph. So that would be here, here. So it's just 2 spaces. So from when x is negative infinity all the way to this value of negative 8, and when x starts again at 4/3 and ends at 7. So we say from negative infinity to negative 8, whoops, the other way, and 4/3 to 7. F, the values of x such that g is greater than 0. So where is g? So we don't care about what's happening with f right now. G of our g of function here is, so it's going to be above this x-axis right here. So we see it here, 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 and to this point right here. So we see all of these values of x are what we're talking about here. So we can see from negative infinity to this value of negative 6, and then again hitting at negative 2, and then ending where this is positive 13. Part G, what's the value such that f of x is less than 0? So f of x is that green function again, and we want to know where is it less than 0. Where less than 0 would be below the x-axis. So where is it less than? It's just less than right here for that f of x. So when I graph that, I know it's going to go from negative infinity up to this point at negative 9, where x is negative 9. Okay, what are the values where f of x is increasing? So take your highlighter if you need to, and we're going to see, okay, where's f of x increasing? So we're increasing decreasing a little bit, increasing again, decreasing again, and then increasing. So we see 3 intervals where they are increasing. So we see from negative infinity to what point is this? This is going to be -7, and then again from -4 to 0, and then again from +4 to positive infinity. So there's 3 areas where we see that. So from negative infinity to -7, -4 to 0, and then 4 to infinity. Okay, what about the value of x such that g is constant? So you're looking at that red function, okay? And we're looking to see where is it constant, meaning where is it completely horizontal. So the only place I see that is right here, and we can see that happens when x is -1 and when x is 3. And remember, on intervals of increasing, decreasing, things like that, it's always parentheses, never brackets. Okay, part J, it says the value where g of x decreases. So we're going to look for g of x, which is that red function, and we're going to see where it's decreasing. So going down and to the right, this is still decreasing until this point right here. So then we're increasing constant and then decreasing again. So we see it here to here. So from negative infinity to where x is -4, and then again from +3 to this positive infinity. So we see 2 areas. So we say from negative infinity to -4, and then again from 3 to infinity. All right, last 2, the values of f of x such that it's greater than 0. So remember, f of x is this green one. If it's greater than 0, it's above that x-axis. So we see it's above it from here, where x is -9, all the way to infinity. So we say from -9 to infinity. And then our last one, it says the values of x such that f of x decreases. So f of x is that green one. We're increasing, but now we're decreasing, increasing, decreasing, and then increasing again. So we see decreasing from when x is -7 to -4, and again from 0 to 4. Oops. And that's it for section 3.